In this chapter, we're going to introduce the list data structure. A list is a way to store multiple data values under a single name. And like I like to do, let's start out with a motivating example to describe or explain why we need lists. So let's say I want to keep track of some grades in a class so that I can compute the average. Or for whatever reason, I just want to keep track of grades. Well, without a data structure to do so, I have to keep a variable for each grade. So for this example, I'm going to keep the data set size small and only show 3, but in a typical class, there might be 20, 30, 40 students. So you can imagine 40 variables. Well, here I have 3 variables. Then I have to assign scores to those grades. So I do that for each variable, and that's really the easy part. So if I want to compute the average, the first thing I'm going to have to do is create a variable called sum and individually add the grades to the sum. And again, imagine that there's 20 or 30 grades and not just 3. Then I compute the average, and then we can display the average. So let's run that program. So the average is 86. Now, that's not too bad, but again, we're working with a very small data set. With a lot of data, this would have been a very hard program to write. Now let's look at how we do it with a list. I'm going to demonstrate some of the features of a list without describing them in too much detail now. We'll get to that in the rest of the chapter. So the first thing I want to do is create the list. So I do that with the keyword list. That's the name of the data type. Then we have to tell it the type of data we want to store in the list. In this case, it's going to be integer values, so I have to put int in what I call angle brackets, greater than and less than sign. Then I provide the name of the list. Then I call the constructor with empty parentheses like so. And that's what you have to do to create a list object. Then, when I want to add items to it, I simply call the add method with the data that I want. I don't have to worry about the size. The compiler automatically adds items for me when I need them. Now, if I want to compute the average, I can do it very simply. Double average is equal to grades.sum, which will add the grades for me, divided by grades.count, which will tell me how many grades are in the list. And then we just display the average. 86. One of the best features of a data structure like a list are these methods, sum and count, which can save me a whole lot of work. Without having the sum method, I would have to write a loop to loop through all the grades in the list. Without count, I'd have to loop through the list of grades and create a counter variable to keep track of how many grades are actually in the list. But now I can do the sum and the count with one method call. There are a lot more to lists than just what I've shown you here, but this is a good introduction to how lists work in C#. And in the following lessons, we're going to learn a lot more in depth about lists. So let's move on to the next lesson where we're going to talk about how to initialize lists. The first step in working with a list in C# is to declare the list. The way we do that is we use the keyword list first, followed by the data type. We'll start with an integer example. After that is the list name itself. We'll use numbers here like we did in the last lesson. Then we have to call the constructor for the list class, so we type new list, again the data type, and then a set of open and close parentheses. Once again, the keyword list, followed by the data type, followed by the list name, equal sign for the constructor call, and then new list, again the data type, and open close parentheses. Let's look at a couple other examples from other data types. So we can use string here, or we could have Boolean, or char. And those are all different ways to declare a list. Now, a couple of things that don't really involve the declaration of a list, but some things you need to know. When you declare a list, you're not actually creating any size for the list. The way we can tell that is by calling the count property. In the last lesson, I used parentheses after count, which you can do, or you can use it without parentheses where it becomes a property rather than a method. Both ways work in C#. C# kind of combines old ways from earlier versions of .NET with things that you're used to seeing in Java. But we can call count like this. Let's add a little description here. There we go. And now let's run this program. And it says the number of items in numbers is 0. And that's because all we did was declare numbers without actually giving it any size. A list size is only increased when we add items into the list. There's no other way to increase the size. There is one other property called capacity. Capacity tells the compiler that you want to initially have 10 items in the list. Let me explain how that works. Every time you add an item to a list, the capacity of the list grows by 1. You can make your list more efficient by initially setting the capacity to however many items you think is going to be in the list. If I know my list is going to have 10 items, then by setting the capacity to 10, the compiler won't allocate space every single time I add a new item. Only after the 10th item is added, then new capacity has to be allocated. So while you don't have to set the capacity of a list, and in a lot of the examples I'm going to show in this chapter I won't, to save a little bit of time, you can do so and save a little bit of efficiency. But again, it's not necessary to do that. But even setting the capacity doesn't change anything. If we look at the size again, by calling count, we'll see that that hasn't changed. The only way we can change the size or change the count is by adding items into the list. So the main thing to know about declaring a list is that you need to know the data type, which you put in angle brackets, and that you have to call the constructor with syntax like you see highlighted there. And that works for all the built-in data types, and it would work for data types you create. And we'll see how to do that when we create classes later on in the course. We'll create lists of our class objects in which we use our user-defined data type instead of a built-in data type. So that wraps up this lesson on declaring arrays, and let's move now to the next item of importance, and that's how to initialize a list once you've declared it. There are times when you want to declare a list and add data to it at the same time, and you can do that using what's called an initialization list or an initializer. Let me demonstrate how to do that in this lesson. We're going to create a list of numbers again. We'll do strings here in a moment. So we know how to declare the list. That we've covered several times. If we want to initialize it with some data, we can do that by putting a opening curly brace and then a list of data, in this case numbers, inside curly braces, so we close the curly brace, separated by commas, so that now we've initialized numbers to be the list 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The only thing you have to know is the list is delimited by curly braces, an opening curly brace and a closing curly brace, and each data item must be separated by a column. Let's do another example. Let's do string this time. In this case, these are strings, so we're going to have to separate them by quotes. So we have Bob, Carol, Ted, Alice, close, semicolon. Works with any data type, so we can do, I see a mistake I made right here. Let me go back and fix that. So here's a list of Boolean values, and we'll do one more, char. We'll stop there. So to initialize a list, you simply provide a list of data separated by commas and delimited by an opening and closing curly brace. Once you've initialized the list, that data is already stored in the list, and you can either work with the items in the list or add new data to the list or whatever else you need to do. Now that we've seen how to declare and initialize a list, we're ready to move to the next lesson where we demonstrate how to add data to a list that's already been declared. Now we're ready to see how to add data to a list in the normal course of a program. So let's get started by creating a new list of numbers. The way we add items or data to a list is with the add method. So for example, adds the number 1 to the list. That adds the number 2 to the list. Every new add puts the item directly next to the previous add. You can add either in individual statements like so, or what you might do is you might put your add statement into a loop. This will only work if you're adding sequential numbers like this, but this will speed up the process of putting data into my list. In a future lesson in this chapter, I'm going to show you how to generate random numbers so that you can work with a wider range of numbers rather than just numbers that you create in a loop like this. This is really the only way to add data to a list once it's been created. Of course, you can always initialize a list when you're declaring it and add data that way. But if you want to add data to a list after it's been declared, like in this example, you use the add method to do that. Since there's not much else to say about add, let's move on to the next lesson where we're going to look at how to access our list items. In this lesson, we're going to talk about accessing list elements. We'll begin by first creating a list. Again, we'll work with numbers. This time we'll create an initialization list. Give us 10 elements, the numbers 1 through 10. And let's say I want to display the first 2. So I do that by using something called subscript notation, where I reference the list name and then the element I want, the numbered element of the list, in a subscript, which is actually the number in between 2 brackets, like so. So here's code to access the first 2 elements of the list. Notice that the first element in the list has a subscript value of 0. That's because we number the positions in a list starting at 0. Sometimes this is called offsets, so that the first element is at offset 0, the second element is at offset 1, the third element is at offset 2, and so on. I don't commonly use offset, I usually just say subscript. So let's run this code real quick. So 1, 2 are our first 2 elements, so that's right. And that's all you have to know about accessing list elements, at least for the purposes of this lesson. Now let's look at a little more involved example. Let's say we want to compute the sum of the elements in this list. So to do that, first thing we're going to do is create a variable called sum. Then we're going to write a loop. Yes, I know in the first lesson I used a method sum to return the sum easily, but I want to demonstrate how to access elements. We'll get back to the sum method later. So the code is for int I equals 0, I less than numbers dot count. Well, let's think about that for just a moment. Count returns the number of elements in a list. So in this particular list, there's 10 elements, 1 through 10. But the I is going to represent the subscript. So if we went to 10, that would be 1 too many. The last element is at subscript 9. So we want to go less than count by 1. So we don't want 10, we want 9. Then we want to increment I by 1 each time. And then we're going to write sum plus equal numbers sub I, so that we get each element of the list by its subscript. And then we'll write out our result. The sum is, and that sum should be 55. So let's run it. And it is. Let's work with one more example just so you don't think everything is based on numbers here. Let's create a list of strings and access those elements. So we're going to write list string names equals new list string. And we'll write 4 names here very quickly. Let me scoot my panel over, give you a little more room so you can see what I'm doing here. Here we go. For int I equals 0, I less than names dot count, plus plus I, console, right line, names sub I. I'll say sub when I'm talking about the subscript. Let's run this piece of code. And there's our 4 names. So to sum up, when we want to access list elements, we use the subscript to reference the position of the element in the list. This is not the only way to do it. Later in the course, I'll show you how to access list elements using something called a for each loop, where we don't have to reference a subscript or a position at all. But for now, because all we know is the for loop, we're going to have to do it by subscript. we write a subscript by putting the number of the element we want inside brackets, and of course it can be a variable as well. One thing we don't want to do is try to access beyond or before the first element in the list. That will cause an error of some type that we want to avoid. So that's why in our for loop we always write loop control variable less than names.count. By doing that, we ensure that we never go beyond the end of the list. So rather than put a number in like 9, because I think that's the size of the list or the count, I'll just use the computer to compute that for me. So names.count will always be correct. Accessing list elements is quite simple as long as you understand the subscript notation. So let's move on to the next lesson where we look at how to use lists in method calls. Lists can be passed as arguments to methods, so in this lesson we're going to look at some examples of passing lists to methods. Let's start out by first creating a list. It will be numbers again. This time let's make it grades, and we'll put a few grades in. I'm going to make these even numbers to make it easy to look at things like average. Initialized into the grades list. I'm going to add a console read key. Now, the first method we're going to create will be a general method that could display the contents of any list. So we're going to call this method display list. Now, it will have to be of integers, but it could be any type of list. We're going to call this LYST. Thinking of some good generic name for it. So all we have to do is loop through the list as we're used to doing already. So we're going to go from 0 to less than count, and we'll do a console write line, although we wouldn't have to do it that way. List sub I, like so. So let's call this method in our main program, and there's our list. The next thing we might want to do is create a method that will compute the average of the grades. So we'll call this one static double average. And again, our list has the one parameter. Bring the screen down a little bit here. Okay, so find the sum very simply, and then return sum divided by list.count. And that's all we have to do. Back to our main program. And we'll do a console write, like so. Let's run the program, and that looks right. So to compute the average, we got the sum and then divided it by the number of elements in the list. Could have done that as a single statement, but I like the idea of showing you how to break it out a little bit, although again it's not necessary. We could have written the method like this. There we go. So we could have done it in one. Let's run it again, make sure that it's right. And it is. So either way works just fine. Now, for this last example, we'd like to take the grades and let's say we decide to give each member of the class 5 extra points. So we want to bump up the grade of each student. So this is a void method. We'll call it curve grades. And again, our parameter is a list. And what we're going to do is we're going to say for int I equals 0, I less than list.count plus plus I. Let me scroll this down a little bit. List.I plus equal 5. Now, notice I wrote this as a void method, and notice that I'm passing the list by value. But actually I'm not, because lists are considered reference objects by default. And when I do that, I don't have to specifically pass it by reference because it is a reference object. Let's go back to the main program. We'll call the method with our list of grades, and then we'll display the list again. We may need a blank line right here. So let's put a blank line in. There we go. So let's run the program. So our first set of grades was 50, 60, 70, 80, 90, 100. Now it's 55, 65, 75, 85, 95, and 105. So as you can see, the method curve grades permanently modified the list that we passed to it, even though we didn't specifically or explicitly pass it by reference. But again, lists are reference objects by default, So you don't have to specify ref when you're passing them by reference. The compiler would just treat it as a reference object anyway. So there are 3 good examples of how lists can be passed as arguments to methods. So now we're ready to move to the next lesson, where we're going to discuss how to create random sets of data for our lists, especially numeric data, by learning how to generate random numbers. When we're working with lists, we sometimes need large data sets. For example, if I want to test a method that I've written to compute the average of a set of grades, I want to test it on a large set of data, more than 10 or 20 elements. Trying to assign those elements manually will be really hard. So what we want to do is create a random number generator, or code that randomly generates numbers, and then assign those numbers to our list so that we can test the methods that we write. So in this lesson, I'm going to show you how to generate random numbers and use them in your code. So first thing I want to do is create a method that will allow us to view a large data set. So we're going to call this method display, and it's going to have one parameter, a list. And so what we're going to do is we're going to write a for loop that says for I equals 0, let's space it out better there, I less than list.count plus plus I, if I mod 25 equals 0, console write line. And what I'm doing here is I'm saying if the value of I modulus 25 is equal to 0, in other words, if the value of I will evenly divide by 25, then we want to put a new line, because that would be like the 25th item, the 50th item, the 75th item, the 100th item. Else, console write list sub I plus a blank space. So this way I'll get a display of items 25 per row. That's what I'm shooting for. So that's our display method, and that really has nothing to do with random number generation, but we need that to display the numbers that we're going to generate. Now let's talk about random number generation. C# has a class just for random number generation. It's called the random class. So if we want to create a random number generator, we create an object of the random class. We're going to call ours rand, and we simply call the constructor with no arguments, the default constructor, to create the random number generator. That's easy enough. Now let's create a list. We'll call it numbers. Now we're ready to use the random number generator to populate this list with a set of numbers. So we're going to say for int I equals 0, I less than 100. We could have started at 1 and gone to 100, but this is fine. Plus plus I, numbers.add, now here's where the random number generator comes in, rand.next. The next method will return a random number in the range that I provide, from 1 to 100, but for the upper bound, I have to go one beyond that. So if I wanted to generate random numbers from 1 to 99, I would have put 1, 100. But to generate random numbers in the range of 1 to 100, I have to write 1, 101. As long as I do that, then I will get a random number in the range of 1 to 100. So rand.next returns an integer in the range specified by the arguments. Once I've done that, then all I have to do is display the list to see if my numbers are generally random. And the reason I created this special display method was so that I could see the list in some sort of order to kind of get a good idea of how random the numbers really are. So let's run this, and then we'll talk a little bit more about random number generation. All right, so there's our set of random numbers. Let's run it again. And we get a different set. One of the things you may or may not know about random number generators is that if you don't properly seed, S-E-E-D, the random number generator, you can conceivably regenerate the same pattern of numbers over and over again, because random number generation is really only pseudo random number generation. It's not absolutely random. Seeding the random number generator is too technical to really talk about in this lesson, but just know that by seeding the random number generator with an appropriate value, you will not run the risk of generating the same pattern of numbers over and over again. We don't have to worry about seeding our random number generator because the default constructor, which we called up here, automatically seeds the random number generator using a system time value. Every time we create the rand object, it seeds the random generator with the current time, which will be different than the last time we created a random number object. So we're always guaranteed of getting a new seed every time we call this line of code. So let's run it again. Notice the first number, 14, the last number, 2. Let's run it one more time. This time 78 and 38. So you'll see we're getting a different series of numbers. I'm not looking exhaustively at every single value, but I feel very confident that I am getting a different set of random numbers every time I run the program. So for all practical purposes, this is all you need to know about random number generation to use it in your programs. You call the random class and create a random number object called the default constructor. Then when you want to generate a random number, if it's an integer, call next with a range. If you don't want a range, then leave both arguments blank and you'll just get a random number. But I generally like to generate my random numbers within a range. If I'm looking at test scores, then what I might do is I might say, well, for the most part, no one's going to score below 50 and no one's going to score greater than 100. So I'm going to set my range there. And then my numbers all fall within that range. If I'm not worried about it and I just want numbers from 1 to 100, then I set it back to 1. If I don't want random numbers that are integers, I can type next double and get doubles in that value. There it is right there. I left off a parenthesis. Let's add that parenthesis back in. Now let's run it. Oh, that isn't going to work because I've set my list up as an integer. Let's change it to double. Display is working with integer. We'll change it to double. It's no big deal. Okay, keep getting an error on next double, so let's just look and see what the problem is. Again, well, if looking at IntelliSense, it says that next double returns a random number between 0 and 1. Okay, so what we want to do is we want to write next double times 100. And that really messes up our display. But it did work. But let's take it back to where we were before. Turn everything back to int. Test it one more time. So that's how we generate random numbers. And we're going to use this ability to generate random numbers in the next lesson, where we talk about how to search through a list for a particular element. In this lesson, we're going to learn how to use C#'s built-in methods for searching a list for a particular item. We're going to start off by writing another method to build a list. So let's do that real quick. First thing we need is a random number object. So we create that. Then we'll write our loop for int I equals 0, I less than 100, plus I, list.add rand next 101. And that's all we need. And we've already got the closing curly brace, so let's take the space out, add a space right here. There we go. All right, so now we have an easy way to build a list. So in the main program, we'll declare our list. We'll call it numbers. Then we will call the method. Then let's display the list. Now we're ready to search. So we're going to create an item to search for, prompt the user to enter the item, get the item from the keyboard. Now here we get our searching. The easiest way to search is by using a method called indexOf. IndexOf takes an item to search for as its argument and returns the index position of the item in the list unless it doesn't exist in the list, and then it returns a -1. So we can write an if statement that says if numbers.indexOf item is greater than or equal to 0, and we can display where that item is. Item is at position, and then call the method again to return the position of the item. Else console.writeLine item not found. We need a console read key here. Now let's run. So let's look for 52, the last item. Oh, but it's not at the last item. It found it at position 62, right here. So there's actually several 52s. That's a problem. Index of always returns the first item found. In the exercises, we'll write a more robust method for finding all of the items, or letting the user at least know that there's more than one. All right, let's run it again. This time let's scan the list a little bit closer. Let's try 11. 11's at 76. So that's how you search. It's very simple. Index of returns the item. Now, this particular method calls index of twice. What we might do instead is write a method like this. Int position equals numbers dot index of item. And then say if position greater than or equal to 0, like so. Program works the same, but it's a little bit faster because we're not making a call to the method to have to search for the item. We call the method one time and we put the result into a variable and then call the variable. Let's try an item that doesn't exist, 122. 122 not found. There's also a method called contains. We could run our search like this. If numbers.contains item, and then call the index of method down here. "95" is at position 54. So that's one possible way to do it. There's no one correct way. Using the variable position is probably a little bit more efficient, but it's hard to see the difference on a data set this small. So that's how you search for an item in a list. Now let's move on to the next lesson where we talk about how to sort a list into ascending or possibly descending order. In this lesson, we're going to see how to sort a list into ascending order and then also via a trick into descending order. This is a very simple lesson because there's just one method to learn that takes no arguments, because the other two types of sorts are too difficult or beyond the scope of this course. But for a simple sort, we have a method called sort. So let's see how to use it. First thing we do is declare a new list, like so. Then we build our list. Then we display the list. Then to sort the list, we simply call the sort method, sort. Then we can display it again, and that's all there is to it. Here's the original list, and here's the sorted list. I cut the size of the list down to 10 to make it easy to compare the two. There are, of course, algorithms you can write yourself for sorting, everything from the simple bubble sort to the much more complex quick sort or the merge sort, but those are beyond the scope of this course. And to be honest, there's really no reason to write your own algorithm when there's a very good sort already built into the language, which has been debugged and is known to work very well. Notice this sort only works in ascending order. What if we want to display our list in descending order? Well, once we've sorted it in ascending order, all we have to do is call the reverse method to reverse the order. Then we'll display it again. And there we go. The first list is the original list, the second list is the sorted list, and the third list is the reverse sorted list, or the descending order. So sorting is probably one of the easiest things we've learned in this whole course, because all you do is call the method. Like I said, there are other ways to write sorts so that you can actually create your own comparison object to determine how to compare two objects, but again, that's beyond the scope of this course as well. And we'll have to rely on just a standard sort when we need to sort items. That's the last of the information we're going to learn in this chapter. Now we're ready to move to the exercises. And for the first exercise, I'm going to demonstrate how to find the maximum value in a list. For this first exercise of the chapter, we're going to demonstrate how to find the maximum value in a list. So the first thing we're going to do is build the list. We have to declare a list object. Then we build the list using our build list method. I'm going to do this in the main code, but we could also write a method to do this as well. We're assuming that the maximum value is at position 0. Then we're going to write a loop for I equal 1, I less than numbers dot count plus plus I if numbers sub I is greater than numbers sub max, which now is equal to 0, max is equal to I. And that's all we have to do. Now we can write the maximum value is plus numbers sub max. And then to guarantee that that's correct, let's add a display list right here. And that's all we need. So let's give it a shot. And indeed, the maximum value is 95. So if we were to write a method for that, here's what we can do. Static int maximum, provide a list of whatever, and then we'll simply write the code here again. So we write int max equals 0. We can just copy the code right here. And then all we have to do is change numbers to list here and there. Comment that code out. And then right here, we're going to call the method like so. Run the code. And the maximum value is 93. So you see what I did. Maximum method loops through the list, comparing each item past the first item to see if it's greater than the previous item. If so, that index position then becomes the maximum index position. And then up here in my code, I wrote the maximum value is numbers, and then our subscript will be the value returned by the maximum method. Test it again. Is 95 out of that list is correct? Let's do it one more time. I won't write this, I'll leave it as an exercise for the viewer, but you could also very easily modify this method maximum and turn it into a minimum just by reversing the logic that you use in the method. So you might want to give that a try to see how well you're grasping these concepts. So that wraps up this exercise, and let's now move to the next exercise where we write a custom search method that will find more than the first item in a list. For the second exercise, we're going to build a search method that returns a list of index positions of items found in a list in case there's more than one. We can return list objects just like we return any other data type. So let's get started writing the method first. So we start out with the keyword static. We're returning an integer list because we're going to search a list of numbers. We'll call the method search. Its parameters will be a list of numbers and an item to search for. So the first thing we're going to do is create two variables, found at and position, but I'm going to abbreviate that to POS. I'll explain what both of those do in a moment. POS is going to store the position we are in the list, and I'll explain why that's important in just a moment. Now we're going to create a new list that will store the items that we found. We'll call it items. As we find the item in the list, we're going to add that index position to this list called items. Now the first thing we're going to do is look for the item in the list using index of. We'll go ahead and use the position, although we don't have to in this particular case, because the default is to start at position 0, but we will this time because we're going to use it again later. Then whatever that finds, we're going to add to the list. Even if it's -1, it didn't find it, we still need to report that back to the user. Now we start a loop. If we found an item, then we want to loop through the list and look again. So the first thing we do is change our position to the position after where we found the first item. So that's found at +1. So if we found an item at position 12, we want to do the next search starting at position 13. Then we perform the search. Found at equals list index of item pause. If we found another occurrence of that item, in other words, if found at is greater than -1, add it to the list. We don't want to add a -1 if we've already found it one time. Only return -1 if we didn't find it at all. And that's what this line will make sure happens. And that's all we need for the while loop. Return the list from the method, and that's all we have to do. So here's a look at the complete method again. And again, we're looking for the item, adding it to the list, whatever we return, even if it's -1. Then, if we find at least one occurrence of the item, then we go into the loop and loop through and look for more. And then when we're finally finished with that, we return the list from the method. All right, so let's write a program to work with that. We'll keep the list short so we can look at the items. Our build list method is only set up to enter 20 items. We could actually modify the method. Let's just do that right now. Let's change this. Int num items. And then up here, where we call it, we'll tell it how many we want. Okay, then we'll display the list. We'll create a variable to store an item, prompt the user to enter an item, get that item from the keyboard, create a new list, and then, and here's something you haven't seen before, assign it the result of the search method. Search numbers for item, and then we'll display found items. And that should be all we need. Because search returns a list, we can assign that return value to a declared but not initialized list. You'll see how it works in a moment. So let's run the program and see how it works. Let's see if we can find an item with more than one. That's why I left it at that. 50 is in the first two positions. So we're going to enter 50, and it found it at 0, 1. All right, let's do it again so you don't think that's magic. I see two 54s, 54 at 8, and 19. That is the last position. Very good. Let's run it one more time. There's three 32s, 0, 2, and 13. And then let's do it with one that's not there. I don't see 100. Returns a -1. As an exercise, you could also take that list and loop through it and display each element that's found. But I'm not going to demonstrate that there. Leave a little bit of something for your imagination and something to work on your own. So to recap, we've written a specialized search method that searches through a list and returns all the occurrences of an item in the list, or a -1 if it can't find it. So that wraps up this chapter on lists. Lists are very flexible data structures, and later in the course we're going to look at another data structure called an array, which is somewhat like a list but does have some differences. But for now, we're going to move to the next chapter where we take a more in-depth look at object-oriented programming.